Hi all, welcome back. So in this session, we will learn about KNN or K nearest neighbors algorithm, which is used for classification. Okay. So before moving on to KNN, we will see the two different types of classifiers. Okay, and they are called as eager learners as well as lazy learners. Okay. So we can classify your classification models or methods into two different types. First one is eager learners and second one is lazy learners. Okay. So eager learners, you can see it is a given set of training tuples. They will construct a generalization model before. So that means they will be constructing some classifier. Okay, before the input tuple is given for classification, the eager learners will make a model which helps to classify the unknown input sets. Okay, whereas so you can see the most of the classifications algorithms which we have seen up to now, that means decision tree, role based classification, propagation, support vector machine, everything belongs to eager learners, because as you know, in decision tree, if you are taking, first what they will do, based upon the training data set, they will construct a tree, okay, which helps you to classify unknown tuples. Same way, if you are using neural networks, you will be making or modeling a network which will in future helps you to classify your unknown tuples. Okay, so eager learners means they will be making or they will be constructing a generalized model which if they receive some unknown inputs, they are able to classify. Whereas lazy learners means they, once they got the training tuple, they are not going to anything, they are lazy. Okay, they will not do anything, they are not going to construct any generalization models. Okay, they will start working only if they get the input tuple, that means the tuple which you want to classify. Okay, so once they get the input tuple, what they will do, they will check the similarity. Okay, so they will perform the classification, or if it is KNN, they will check for the similarity between the training tuples and the input tuples, and then they will go for classification. So until that stage, they are doing nothing. Okay, so you can see the learner instead waits until the last minute before doing any model construction in order to classify a given test tuple. That is, when given a training tuple, a lazy learner simply stops it and waits until it is given a test tuple. So they will start working only once they get the test tuple. Okay. So, lazy learners do less work when a training tuple. So, what is the main difference between lazy learners and eager learners? That eager learners takes more time for constructing the model. Okay, then for prediction or classification, they will take only very little time. But whereas lazy learners, they have need not time for training, but they needs more training for classification or prediction. So example for lazy learner is K nearest neighbor classifier or KNN. Okay. So you can see nearest neighbor classifiers are based on the learning by analogy, that is by comparing given test tuple with training, that I have already mentioned that. What KNN does is that they will be KNN algorithm will compare the test tuple, that they will start acting only once it gets the test tuple. So will they compare the test tuple with the training tuples. Okay, then they will check for the similarity or they will calculate the distance. Okay, so the training tuples, as in all cases, are described by n attributes. Each tuple represents a point, and when given an unknown tuple, a k nearest neighbor classifier searches the pattern space for the k training tuples that are closest to the unknown tuple. That means if you are using 3NN, okay, 3NN classifier means the classifier will tries to identify 3 nearest neighbors. Okay, what they will do, they will calculate the distance with the this input tuple and every other tuple in your training set. Okay, and they will find out 3 nearest neighbors. Okay, that means the 3 points which are very similar to this input tuple. Okay, they will check the distance and they will find out the 3. If it is 3NN, it will calculate 3 nearest neighbors. If it is KNN, they will calculate k nearest neighbors of that particular point of for that particular input, and then what they will do, and they will check what is the what class of that 3 nearest neighbors, or they will check for the majority class of that 3 nearest neighbors or k nearest neighbors, and that particular class will be considered as a class for this corresponding input also. Okay, so here the closeness or similarity is defined in terms of distance metrics. So you can see different, mainly we'll be using Euclidean distance for calculating the distance in interval scale variables. And if it is but if they want to perform normalization, they will be performing normalization also. So if normalization is required, they will normalize also. Okay. And for if it is categorical attributes, as you know, you can change. If they are similar, they will take it as 1, and if they are similar, then the difference will be 0, and if they are different, the difference taken considered to be 1. And the other one, if the value of a given attribute, if the value for missing for any of the attribute, that will take us the maximum possible difference. Okay, so we'll see with this example. So you can see these are the input or the training tuples it's given, and the input is this one. That means find the t-shirt size for a customer. This is the height and weight of different customers, and this is their t-shirt size. Okay, so we want to find out the t-shirt size for a customer who has height 161 centimeter and weight 61 kilogram. Okay, so here it is given k equal to 5. So we have to take or find out 5 nearest neighbors of this particular tuple. That is h is equal to 161 and weight equal to 61. So what is the first thing we have to do? We have to find the distance between this point and every other tuple in this training set. Okay, so we'll calculate the distance from this for every tuple in your distance set. So here you can, since it is interval scale values, you can use Euclidean distance for calculating the distance. So we'll calculate the distance of this one with every tuple in this training data set. Okay, so we'll be using Euclidean distance, that is square root of. So one example is given for you, that is first one. Here your height is 161 and weight is 61, and for the first tuple height is 158 and weight is 58. So we'll take Euclidean distance, that is square root of 161 minus 158 all square plus 61 minus 58 all square, and that will gives you 80. And same way we will find out the distance for every other. This is the method we have calculated the distance for every other tuple in your training set. Okay, and we will identify the 5 nearest tuples. Okay, so we will find out the minimum 5 distances in this distance, and you can see it is given here. First one is minimum distance is 1.4, then it is 2.0, then you can see 2.2s are there, then 3.2. So these are the 5 nearest neighbors. All other values are greater than these values. So these are the 5 nearest neighbors of this one, and we'll check what is the classes or what is the majority. Here you can see for 4 values it is medium, and for the last one it is last. So we'll check for the majority values. Since here the majority is medium, our class or our particular input tuple belongs to the class medium. That is, the particular customer wants medium size t-shirt. Okay, so that is your classification or how it is KNN works. It is very simple. Only one thing you have, only very little thing you have to do. That is, first one, you have to calculate the distance between the input tuple and every other tuple in the training data set. Then find out the k nearest neighbors and assign that class to the input tuple of which the 5 nearest neighbors, which is having the majority element. Okay, so this is an exercise problem which is left to you. You can try this one, and here this is your training data set. That means this is the speed and agility of athletes for some 20 colleges, and you have to check whether they are drafted by a professional team or not. And here the input tuple, that means you have to check whether a particular student or athlete with speed 6.75 and agility 3.0 will be drafted or not. Okay, so that's your exercise given to you. Please go through it and check it. Okay, so see you in the next session. Okay, so we'll hope all of you will be participating in the discussions, and we can have the discussions either today or tomorrow or next day. Okay, thank you.